This is homework 5, and this one is covering ratio, rates, and proportions. So last homework on homework number 4, we dealt with rates a little bit when we were saying like dollars and then miles per hour. And we're talking about dollars per ounces and a lot of stuff like that. We didn't talk about ratios and proportions in detail, but that's what this section is about. So let's talk about what a ratio is. And I'm going to use a homework example as well to illustrate this. So number 1 says to simplify the ratio 10 to 8. So ratios can be written in different ways. This can be written as 10 to 8, but it can also be written as 10 to 8, or it can be written as 10 over 8. Each one of these means the same thing. So you might see something like this one right here, the 10:8, when we're talking about ratios or parts, maybe if we're talking about a recipe or scale modeling. If you've ever bought like maybe a model airplane or model building, they might say something like, for every 1 inch of this replica on your little model, it represents maybe 1,000 inches for the real thing. That would be something like a ratio. So with ratios, the unit of measurement is the same for them. So the unit of measurement stays the same: inches, inches, miles, miles. We're talking about cups and cups. The ratio stays the same to keep it proportional. Now, whenever we want to simplify any of these ratios, we simplify them much like we did with fractions. So like if I look at this guy over here, this 10 over 8, remember I've taught y'all how to simplify fractions. We want to find the largest number that goes into both the numerator and the denominator, which would be the number 2. If we divide not both sides, the top and bottom by 2, we get 5 over 4. That's what it would simplify to. So this ratio could simplify as 5 to 4, 5:4, or 5 over 4. They all mean the same thing. So your answer for that problem in my math lab, I want you to type it in like this. But any of these answers would be correct. And it just depends what you were talking about. Maybe you want to reduce it completely. So if you're working with, like, let's say recipes, which is talking about parts, and you want to make something proportional, which we'll get into a little later, you might want it in its simplest form so that it's easy to scale either up or down. Maybe you want to make your recipe larger so you can scale all the ingredients up. Or if you want to scale it down, it's easier to scale it down. You might not want like a big number like 10 to 8. So that's all there is to a ratio. Just make sure whenever we're talking about ratios, the unit of measurement is the same whenever we're talking about them. So number 2 wants you to simplify 9 ounces to 12 ounces. Notice it's the same unit of measurement. We can simply take 9 over 12 and simplify it. The largest number that goes into 9 and 12 is 3. So if you divide the top by 3, that gives you 3. Divide the bottom by 3, you get 4. So your answer would be 3 over 4, and you would just type that in as a fraction on My Math Lab. That's all there is to simplifying some of them. There's a couple of other problems with it. But let's kind of talk about an idea we introduced in the last homework assignment. Number 4 says you purchased a 1.5 liter bottle of olive oil for $11.69. What is the cost? And it says per fluid ounce. And I'll abbreviate ounce. So on here, remember the last homework assignment I told you all to write down whatever your goal is. So it's asking, what is the cost per fluid ounce? We talked about that last time. What is the cost, $ per fluid ounce? That's our goal. That's what we want to get as our answer. And we're currently given dollars and a volume. Remember, this is dollars over a volume. So our initial number we want to set up as money over volume. So we'll say $11.69 over 1.5 liters. We set our rate, now it's a rate, again, just like last time because it's two different units of measurement. We set it up as dollar over volume. And our goal is to get what's in the blue over here. So we currently have the dollar up on top, but the bottom is 1.5 liters. We need to change that to fluid ounces. So somehow we'll have to have liters, so they cross out, and then we'll have to have fluid ounces on the bottom. This is where we break out our conversion chart. So I'm looking at the conversion chart. We're going from metric to an imperial measurement. It says 1 liter is equal to 33.814 fluid ounces. And you can check, your liters cancel out, you'll be left with dollars over fluid ounces as your final answer. Go ahead and multiply all the top numbers. I'll just put the number $11.69 and then the 1.5 times 33.814. That will give you 50.721. We can go ahead and divide those two numbers, 11.69 divided by 50.721. And that gives us 0.23047. Keeps going on. Now, this is a cost per fluid ounce, so we went to the nearest cent. So this would be $0.23 per fluid ounce. And that would be your cost for it. So we warmed up to something like that in the last section. So it shouldn't be any surprise that we are seeing it again. Number 5 on your homework is a similar problem like it. Now, let's go over number 6, which is kind of similar. It's a little tricky. It says, on average, one bunch of celery weighs 32 ounces. So I'm going to make that ratio. One bunch of celery weighs, so I'm saying equals 32 ounces. It's funny, it almost looks like lunch. This is a bunch. One bunch of celery equals 32 ounces. It says the celery costs $1.98 per pound. It costs $1.98 per pound. A bunch of celery costs, one bunch costs what? Or we can set it up the other way. We could say question mark dollars per one bunch. That's what we need to find. So we need to find what is the cost right here per one bunch. That's our goal. So since that's our goal, set it up like that. We want to figure out what we have. We want to put dollars over bunches in the end. So it's dollar over some kind of amount. We have $1.98 per 1 pound currently. That's what we're given. Even though a bunch is like an amount, it still kind of relates to the weight. The weight is related to the amount, a bunch. So start out with $1.98 per 1 pound. We currently have the dollar up on top. We need to change this to bunches somehow. So we need to use this conversion right here, but we can't use that one at the top just yet until we convert it to ounces. So we have to change this bottom unit to ounces. So for every 1 pound, you have 16 ounces. That will cause the pounds to cancel out and you'll have ounces left over on the bottom. Then you can use your next ratio. We want to get rid of ounces and we're going to change it to bunch. Yes, it's not a formal unit of measurement, but it works. It can be an amount of something. And if we double check our unit conversions, the pounds cancel out, the ounces cancel out, we'll be left with dollars per bunch. So this would be 32 ounces per one bunch of celery. Go ahead and multiply the top numbers, $1.98 times 32. That gives you 63.36 over 16. and you divide that by 16, you'll end up getting 3.96. Now we're talking about dollars per bunch, so it'd be $3.96 per bunch. And that's your answer for that problem. So the setup is interesting because it wants us to, it asks backwards. It says how much, or it says one bunch of celery is how much. So you want to think like, oh, one bunch per dollar amount in the way that they word it. But you should think of it the other way. How much does it cost per bunch? That's what you want. You don't want this. That doesn't really make much sense. We say, oh, bunch per dollar. We don't hear that. Like, what's your bunch per dollar rate? That's not used very often. So check the way that you're looking at the problem. Make sure you want the correct rate or unit of measurement. So let's go on to examples of proportions. Now, when we're talking about what a proportion is making something proportional. So for instance, if I want to like draw like a square right here. Now that's totally not a square. Got to change it to the square tool. If I want to draw a square and I want to make it proportionally larger, it has to equal or double the size. So I can make it look proportionally larger. What is that, about 5 lines? That looks about proportionally larger. You can see that I can fit a bunch of other little squares that are the same size inside of it. This isn't perfect. I'm just doing this with freehand-ish. So we in fact double the length, oops, that's the wrong tool, the length of the square on both sides. So you can see that this one right here, this side, and this side were in fact doubled more right here and right here. So if I double the sides on both of them, it doubles the area of it. We keep stuff proportional. Think about a recipe too. Like if you make a recipe, say per one recipe, it serves, let's just say, 4 people. Well, what if you want to serve 8 people, which is double the amount? You should double your recipe. So that would be 2 recipes. You need to do the recipe twice in order to feed double the amount of people. That's the idea of keeping things proportional. What happens is over here, it's a times 2, it's a times 2. You could also think of it the other way around. If you're going this direction, it's divided by 2. Divided by 2 for the top and the bottom. But notice what's done to the top and bottom is proportional. Notice how we reduce fractions when I say something like 20 over 14. If we divided both top and bottom by 2, that keeps it proportional, which makes it 10 over 7. That's exactly why we reduce fractions like that. It keeps the proportion for it. But this is a perfect everyday example right here. You want to change your recipe and scale it correctly for the amount of people that you're serving. So if it's something weird, like say, let's talk about like money. Say you have like, I don't know, my first job when I worked as a teenager was at Fiesta, Texas. I got paid like $5.25 an hour. That was pretty rough. So let's just round down because Uncle Sam takes money out. $5 per 1 hour. If I worked 10 hours, I should have made $50. Those are some dark times. 10 hours for $50. That's a little rough. But you know, you do what you got to do in high school to get your savings up. I later then got a job that paid $6 per 1 hour. It was like $6.10 an hour. So again, if I worked 10 hours proportionally, that would have been $60. That's 10 more dollars. But you can see that the proportion is here. Here we did times 10 on both of them. It keeps it proportional. Now, not all proportions are equal in that manner, like it's easy. You can see, oh, times 2, times 5, times 10. You double them or triple them. Well, let's take that other example. Say I made $6 per 1 hour. And let's say I worked something odd like, we'll say 4.25 hours. That's a strange amount. I want to be able to see how much money I would make. Well, you can see that it multiplies by 4.25 for the other one in order to get that, right? The bottom one is times 4.25 because it's a multiple of 1. So this would be 6 times 4.25, which would give me $25.50. So that's how much I would make in 4.25 hours. That would be 4 hours and 15 minutes because 0.25 is a quarter of an hour. A quarter of an hour is 15 minutes. So $25.50. Now, one way to check to see if numbers are proportional is we can look at the two numbers given to us. So like number 12 on your homework says, is 9 over 3 proportional to 12 over 4? And you can see here there's no easy number it multiplies to. So one of the easiest ways is to just simply divide these numbers separately. 9 divided by 3 simplifies to 3. 12 divided by 4 also simplifies to 3. So they are proportional. You also could do something called cross multiplication, where we multiply this times this and this times this. 9 times 4 makes 36. And then 12 times 3 is also 36. That makes it easy as well. I'm going to show you all cross multiplication problem in a minute. So number 13 has a way of, has another set of fractions asking you if they're proportional or not, and you could do that one. But what if we need to find the value? What if there is an unknown value, kind of like what we just did up here, but they're different numbers, and it might be a little bit more difficult to find out if you don't see the number or the multiple right away. This one wants us to solve for n. And this is why I introduced the algebra back in the very beginning of the class. This is proportional. It says equals. So the easiest way to solve this is to take this bottom number, multiply it with the top number, and then take this other top number and multiply it with the bottom number. So I like to have my variables on the left side, so I'm going to do n times 4 first. N times 4 makes 4n. Put the equal sign still. 12 times 3 makes 36. And then, like we learned from the last section, way back in, I believe it was homework 2 and 3, I think we did introduce it in 2, is we need to divide by 4 to get the n by itself. And that ends up giving us n equals 9. So cross multiplication is what got us this answer quickly. So again, you might have been able to see that one right away though. The 12 and the 4 are kind of related. 4 times 3 makes 12, so 3 times 3 would have made 9. That would have given you your answer. But let's look at number 16, for instance. 21 over 4 is equal to n over 6. If we look at this, go ahead and cross multiply again. As long as you do the top multiply with the bottom of the other one, they have to be alternating. 4 times n again makes 4n, and then 21 times 6 makes 126. But as you can see, there's no like easy correlation that you can see intuitively or right away on this problem. You can't see, oh, it's a multiple of 3. Go ahead and divide both sides by 4. 4's cancel out, and you end up getting 31.5. That would be a more difficult number to come up with mentally. Some could do it. I personally don't like to chance anything like that. It doesn't matter how easy it may seem to me, I'd like to calculate things pretty thoroughly, so I just make sure they're right the first time. That's how I get in good habits with making Excel spreadsheets and such. So let's do number 18. This is an example of making a proportion with, like, let's say, a culinary example. Actually, I'm going to do number 19. For this one, this is the math textbook that comes up with this, but they're saying for every 5/6 cup of water, you need 5 tablespoons of veggie oil. I don't know what's going on here. I don't know what's being made. I mean, they probably may oil up the pan, then you have to pour the water in later on, like in the recipe, if you're maybe cooking beef or something, to stew it a little, give it some moisture. But that's what the recipe calls for in this math book. So every 5/6 cup of water, you use 5 tablespoons of veggie oil. Sounds like a lot of veggie oil. It's asking, well, what if we have 10 tablespoons of veggie oil? How many cups of water do we need? In cups of water. This is a practical example. Like if a recipe calls for a certain amount of something, well, if you increase that amount, like if you use instead of 1 pepper but 3 peppers, how do I scale the rest of the recipe accordingly? How do I scale all the other ingredients? And we'll learn something like that in the next section when we deal with scaling, recipe scaling factors. But if you want to do one ingredient at a time, you can do a proportion like this. Notice in a proportion, we always have cups to cups, veggie oil to veggie oil. They cannot be the opposite, meaning if you add water, I'll put it over on the other side. Let's say you had water to veggie oil, and then you accidentally put veggie oil on top of the other one to water. This would not be proportional because the units of measurement do not match. They got to match. So the top units have to be the same thing that we're talking about. They both have to be talking about, water. Got to make sure we're talking about water, and they have to be cups of water. If one of them said a pint of water and the other one said, like if it said pint of water and the other one said cup of water, and the two bottom ones still said tablespoons of veggie oil, it's still not proportional because even though it's water to water, it's not pints to pints or cups to cups. You would have to convert. So this would also be wrong. You have to make sure the entire unit of measurement is there. Cup of water, tablespoon of veggie oil, tablespoon of veggie oil. Once you make sure that those are equal, you can go ahead and do the cross multiplication. So I'm going to do, we can ignore these units of measurements. If it helps, you can get rid of the units of measurements and just write down the numbers to kind of clear it up a little bit. We always know that N is going to represent cups of water in the end. Cross multiply. We go ahead and do 5 times N, and then we do the 5/6 times 10. This gives us 5N is equal to 5/6 times 10. You can simplify that however you'd like. I'm going to go ahead and multiply 5 times 10. So this will give us 5N is equal to 50/6. And then we can reduce 50/6 to a whole number or to a reduced fraction. We can divide both of them by 2 if we want to make it look a little simpler, which is 25/3. Then we would have to divide both sides by 5. If we divide both sides by 5, 25 divided by 3 divided by 5, that gives us 1.66666, and equals 1.6 repeating. And then 0.6 repeating would be 2/3. So on your My Math Lab, there's different mixed numbers that you can type in. They have a improper fraction tool. They have a mixed number tool. You have to use each one of those for it, and it's a little tricky sometimes. I'm doing it right now to type them in. But 1.66, you get that number, it'd be n equals 1 2/3. That's what you have to type in. So remember that represents cups of water for your end answer. A little tricky in terms of like the fractions, but the actual process involving the proportion portion of it isn't too bad. Let's look at number 20. This one says the directions on a bottle of bleach say to use 3/5 of a cup of bleach for every 1 gallon of soapy water. So it wants 3/5 of a cup of bleach for every 1 gallon of water. It says Ron needs a 5-gallon mixture. So we're going to put 5 gallons on the bottom. It says mixture, but they mean like water. The 5 gallons of water, and then we put the bleach on top of it. It's asking how many cups of bleach. So n cups of bleach. How many cups of bleach do we need? You can check. It's gallons to gallons of water, and it's cups of bleach to cups of bleach. Don't need to do any conversions or anything here, since the top is equal to top, the bottom is equal to the bottom. All you need to do is cross multiply. So 1 times n ends up making n. 3/5 times 5, you can see the 5's cancel out. You end up getting 3 as your answer for that. Now, the question seems a little questionable in the way that it's wording it. It's saying Ron needs a 5-gallon mixture. And yes, we understand that if I add 3 cups on top of the 5-gallon mixture, that would make it 5 gallons and 3 cups of a total mixture. So the math textbook worded it a little weird. I don't really like the way they worded it, but they should have said something like, oh, 5-gallon mixture, and then you add the bleach. It's not total afterwards. It's not saying a 5-gallon mixture including the bleach. Then we would have to do some subtraction and then scale down the total amount, and that's just a pain. So they were kind of paraphrasing with the way they worded it. All right, so let's check out number 22. This is another one. In his curry chicken recipe, this is a math lab created question. I don't know how accurate it is culinarily speaking. Louis uses 4 cups of curry sauce for every 5 people. So notice I start setting it up as a proportion right away. How many cups of curry sauce? Okay. In cups of curry sauce. You can put X or Y. Doesn't matter what this variable is. It could be X or Y or Z. N is fine. How many cups of curry sauce for a dinner party of 47 people? Check the units of measurements. It's cups of curry sauce, and it's people to people. So we're set to go ahead and cross multiply. 5 times n makes 5n, and then the 4 times 47 makes 188. Divide by 5 on both sides. 188 divided by 5. N equals 37.6. Now, on your My Math Lab, it'll ask you to put that as a mixed number. Remember, this is the tenths place. So this would actually be n equals 37 and 6 over 10. Yet 6 over 10 isn't simplified. 6 over 10, you can divide 2 into both of the numbers. That would give you 37 and 3 over 5. That would be the answer that My Math Lab wants for that question. So a lot of your questions from here on out on the My Math Lab involve a lot of setting up proportions like that. And I'm leaving a lot of them for y'all to do by yourselves because I want y'all to get practice of setting up those proportions correctly. But the next thing I want to talk about is parts. So whenever you have recipes that are normally by parts, usually like when you mix drinks too, it's always like 2 parts this, 1 part that. Like for instance, I like to make it old fashioned every now and then. I do like 2 parts bourbon and then 1 part simple syrup, and then I'll do just like a little orange wedge and stuff. So this, spruce it up, and it says like 6 dashes of bitters, but that's a number. But notice the parts. For every 2 parts of this, it's 1 part that. Usually that's how it's done. Like a margarita mix might be, for the adventurous, it might be 3 parts tequila or 2 parts tequila. It depends. And then you'll do 1 part simple, or not 1 part simple, so you do 1 part triple sec, and then maybe you're adding a margarita mix on top of that. Like it's like a lime juice or a watermelon juice or something. Maybe you'll make that 3 parts or something. So illustrating that, it's different. You can have a 3-2-1 parts ratio, 3-1-2-1. There's a bunch of different part ratios. But let me illustrate that even more by looking at 27. So this is a culinary example. The weight ratio, so all these ratios can be done by weight or volume. The part examples I just gave earlier, we're talking about liquid measurements, so volume. This is a weight ratio. You can have weight parts as well. The weight ratio for cookie dough is, so this is for cookie dough. I'll go ahead and write it down here. Cookie dough. It's great in blizzards and ice cream. Good for bacon too. Baking, not bacon. It says it's 3 parts flour and to 2 parts fat and 1 part sugar. That's the recipe in terms of weight. So, flour, fat, and sugar all weigh differently, per unit of measurement, right? Maybe a cup of flour, a cup of fat, a cup of sugar are all going to weigh differently. But you're doing this by weight. And in baking, you do a lot of things more so by weight than volume because you want to measure out the weight of your sugar, the weight of your flour, and everything else. So we look at each part in this. What we can do is we can add up all of the parts. 3, 2, 1 all add up to 6 parts total. Now, on this question, it's saying if you use 5 pounds of fat to make the cookie dough, if I do 5 pounds of fat to make the dough, you should use question mark pounds of flour. So it's question mark, or they put a blank, pounds of flour. What we can do is then refer to our recipe here at the top, how we make it. This is a weight ratio that we have. So we can set up the different weight ratios. Notice the one we're looking at is fat to flour. So what I can do is fat to flour, I can make a proportion for it. I can say another one of fat to flour. Since it's a weight ratio that all this is in, we look at the numbers in front of it. So notice fat is 2 parts, and then flour is 3 parts. So for fat, we're going to do 2 parts, and then for flour, we'll do 3 parts. So I'll say 3 parts, 3 parts. And then in this other one, what we're going to do is we're going to put our information that's given to us. This would be 5 pounds of fat, and then we'll just call this X pounds of flour because that's what we need to figure out. Now, since these right here, parts and pounds, yes, they're not like the same looking unit, but because this recipe is weight-based, that means our units of measurement on the first part are weight-based. So you can change this. Instead of saying 2 parts and 3 parts, you can say 2 pounds of fat, to 3 pounds of flour. Now you make sure the units of measurement match. So we can see that it's pounds of fat to pounds of fat, pounds of flour to pounds of flour. Once we have our ratio set up, we go ahead and cross multiply. 2 times x makes 2x. 3 times 5 makes 15. Divide both sides by 2. We end up getting x equals 7.5. What did 7.5 represent? It was pounds of flour. And that would be our answer. So whenever you're creating these proportions, you look at your whole entire recipe, even the total, which we'll talk about in a second, and you make up your own ratio. Here I did a fat to flour ratio. I'll write that in. I did a fat to flour ratio, which then I'd have to set the other side fat to flour. Now you could have set it as flour to fat if you wanted to, as long as the other side is flour to fat. You would have gotten the same answer. Both would have resulted in the same answer as long as it's proportional. That's how the math works out. So you choose what you're looking at. Oh, we're dealing with fat and flour. I need to make a proportion of fat to flour and then take those proportions out of the recipe. I don't need sugar at all. That's not important. We can figure that out if you need to, you know. Obviously, you would need to if you're making cookie dough that doesn't match the entire weight base. You would have to figure that out. But the question is only asking for those two fat and flour. So let's try another problem. Let's look at number 28. It says the weight ratio for Mirepoix is 2 parts diced onion. 2 parts diced onion. I'll just put the dice because it's good for the recipe. 1 part diced carrot. And then it says 1 part diced celery. Let's go ahead and look at that. We see that we have 4 parts total. So it says if you need 10 pounds of Mirepoix to make stock, so it's asking for the total amount, you should use how many pounds of diced onions? So 10 pounds of Mirepoix, we need how many pounds of onion? So to look at this, notice this is the total for the Mirepoix. We want a total of 10 pounds. So this right here, this bottom number represents the total. So we need to have a total to onion ratio or onion to total ratio. So I'm going to do that. I'm going to do onion to total ratio. So in this one, our onion is 2 parts and our total is 4 parts. Here our total in this respect is the 10 pounds of Mirepoix. And then our top is X pounds of onion. So we can see it's onion to onion and Mirepoix to Mirepoix is the total for this one. We can go ahead and set up the cross multiplication. 4 times x makes 4x. 2 times 10 makes 20. Divide both sides by 4. You end up getting x equals 5. So this would be 5 pounds of onion are needed for 10 pounds of Mirepoix. And that makes sense because diced onion is 2 out of 4 parts. So if it's 2 out of 4, it should be half of the total recipe. So if you needed 20 pounds of Mirepoix, you would need 10 pounds of onion. So you can look at it in that respect as well, since it's a fraction. If you had, let's say, 20 pounds of Mirepoix, you needed 20 pounds of Mirepoix, but you need to figure out how many diced carrots you needed. Well, that would be 1 out of 4 of the total, so it'd be 1/4 of 20. So that would be 5 pounds of diced carrot. It would also mean 5 pounds of diced celery. So you can do that to figure it out too if it's a quick fraction like a third or a fourth or a fifth. How much does it represent of the recipe? 2 out of 4 would be half of the recipe. So a lot of different ways to come about finding this answer. Either way is correct. You can use whatever is at your disposal. Okay, so lastly, I want to go over one other one that where you have to find out all the different ingredients according to all the different parts. This is number 31. It says a weight ratio for trail mix is 2 parts rolled oats. So this is for trail mix. It's 2 parts rolled oats, 1.5 parts raisins, 1.5 parts peanuts, that's an A, and then 1 part dried cherries. What we want to do is then figure out the total. If we add up all those numbers, 1.5 plus 1.5 makes 3, plus 2 makes 5, plus 1 makes 6 parts total. It's saying you need to prepare 64-ounce portions. We need 64-ounce portions of trail mix for a Girl Scout troop outing. How many pounds of each ingredient do you need? So, question mark, pounds of each ingredient. Let me erase this little line. Now, look at this word. It says 64-ounce portions. So think about like 60 little baggies or something, whatever they're putting them in, 60 little boxes. That's what it wants. So it wants 60 separate portions. But before you put them into separate baggies, you have to make it as a whole. Then you distribute it into separate little baggies. So we need to figure out what our total actually is. Notice it's asking for pounds as our total. It's saying question mark pounds. I should circle that to make sure it's seen. So our overall answer needs to be in pounds. We need to figure out how much we have or want to currently have. So we need 64-ounce portions. That would be 60 times 4 ounces. That makes 240 ounces total. Now that number 240 ounces is difficult to work with because it's a high number. If you want to do things mentally, sometimes you always want to reduce the number down. And since our question is asking for all the ingredients in pounds, we should change 240 ounces to pounds. So change 240 ounces to pounds. Remember, there's 16 ounces per 1 pound. We can divide the number by 16. So 240 divided by 16 ends up giving us 15 pounds. Now here's where we want to figure out the fraction of each ingredient. Instead of setting up a separate proportion for each one, I want to find out the amount for every one of them. So let's look at the recipe. 2 parts of rolled oats. So for rolled oats, I'll go ahead and do rolled oats and let's say blue. This would be 2 out of a total of 6. So it'd be 2 over 6 represents the rolled oats part. So 2, 6, which is 1/3 of the recipe is represented by rolled oats. The raisins is 1.5 out of 6. So 1.5 out of 6. The peanuts is 1.5 out of 6. And then finally, the cherries represent 1.5, or not 1.5, I'm sorry, 1 out of 6 for the total. So what we're going to do with this is, remember, these are fractions for each ingredient separately. Remember, we can take the fraction of the total. like we did over here on this other problem. We could have done 2/4 or half of the recipe is represented by onions. Here we're going to do the same thing. 2/6 of the total. So whenever we think about the word of, we think of multiplication. The total is 15 pounds. This one is 1.5 over 6 of the total. Of the total. And then finally, of the total. And it gives me a little bit more room. But you can see that we multiply the total by the fractions to find out each individual answer. So for the first one, 2 times 15 makes 30. 30 divided by 6 ends up making 5 pounds total. For the other one, I'm going to put equals in black for all these. For the next one, 1.5 times 15 makes 22.5 divided by the 6 on the bottom. That makes 3.75 pounds. That would mean the same thing for the peanuts. This would also be 3.75 pounds. And then for the dried cherries, 15 divided by 6 ends up giving us 2.5 pounds. So our final answer for this would be 5 pounds of rolled oats, 3.75 pounds of raisins, 3.75 pounds of peanuts, and then 2.5 pounds of dried cherries. So anytime you have a total amount you want to make, and you want to put it on an entire recipe like this, have your ratios set up and then your total. And all you do is take each ingredient divided by the total, each ingredient divided by the total, ingredient divided by total, ingredient divided by total to find out the ratio that you need, the fraction. You take that fraction and multiply with the total amount you want. So if we wanted 30 pounds as the total amount, well, we would just replace this number right here with 30 for each one of them, and that would give us our each fraction of the amount for all the other ingredients. So if I did 30 pounds here, since that number's doubled, I would then need 10 pounds of this. That would double that. 3.75 times 2 is 7.5. This would have been 7.5. This would have been 5 pounds. That's how it works. Take the fraction of each one and multiply it by the total. It's the easiest way to find out all of your ingredients whenever you're making anything. So if you want to scale the Mirepoix that we were talking about earlier for all of the ingredients or any kind of complicated recipe, you can just scale everything like that in terms of parts. Just take the fractions, multiply them by the totals. All right, this is a pretty heavy section, homework 5. This is an important section. We're going to still use this stuff as we go down to the other homework assignments. So be sure to have it down. Homework 4 and 5 cover the information for quiz 2. The next homework assignment, homework number 6, is quiz number 3 topic related. So go ahead and finish up homework number 5 and attack quiz number 2.